Today's topic is throwing a ball upward, and the purpose is finding time, elapsed time, 6 different ways. So what are we talking about? We are talking about an action. What is the action? Throwing something upward. As simple as this. Let's translate this action to an equation. This action you should be able to translate to an equation. Y is equal to negative 5x squared plus 15x. Since we are talking about the time, you can replace x by t. So now this equation is screaming at you, telling you that I am an action, and the action is throwing something upward with initial velocity. The initial velocity is given, as you see, positive 15. If you don't give initial velocity, it don't go up. And right here you see the acceleration. Acceleration is negative 10. Acceleration due to gravity, of course. Alright, to understand it a little bit more, if you don't see acceleration negative 10 over here and initial velocity 15 over here, you write it a little differently. You tell the story different way. Hopefully that way you would notice you would notice the initial velocity and the acceleration. What am I talking about? Let's write this equation. D is VAT plus half AT squared. So then D is plus half, this is negative 10 t squared. So D is equal to plus and minus 5t squared. Okay, so this is acceleration due to gravity, of course, and this is 15t. So 15t minus 5t squared, and that's exactly what I gave you. All right, now let's see if you still don't see this is throwing up. You draw a picture, you see the geometric version of the same story, throwing up a ball in the air with 15 meters per second. So this is displacement versus time, and this is a parabola. This ball initially here, and the ball is here, and the ball is here. We want to call this is location 1, and this is location 2, and this is location 3. We want to find few things. Let's create a table. We want to write the location 1, location 2, and location 3. We want to find time at location 1, 2, and 3. We want to find the velocity at location 1, 2, and 3. We want to find the acceleration at location, or let's say distance or displacement at location 1, 2, and 3. We want to find the distance at location 1, 2, and 3. And we want to find the acceleration at location 1, 2, and 3. Okay, so we want to find a lot of things. Alright, now let's first find the time. At location 1, the time is 0, of course. You start the measurement, so the time must be 0. At location 2, the time is t over 2. Since this is a parabola, if you know the elapsed time, this is sometimes called elapsed time. This is sometimes called elapsed time. This is sometimes called hang time, or this is sometimes called total time. They are the same thing. If you know the elapsed time, you divide by 2, you know the time at location 2. Alright, good. Now let's find the velocity. Velocity at location 1 is 15. And velocity at location 2 is 0. Why 0? Because the ball changes the direction. Let me show you why it is 0. This is the half of the parabola. This half of the parabola, this is, let's say, location 1, and this is location 2. At location 1, initial velocity is 15. So velocity is upward arrow. At location 1, acceleration is downward arrow. So 15 become 14, become 13, become 12, become 11, become 10, become 9, become 8, become 7, become 6, become 5, become 4, become 3, become 2, become 1, and become 0. Why the speed or velocity decreases? Because the velocity has to fight with the acceleration. Alright, so there is a tug of war. This is why velocity decreases, and eventually velocity is 0 at the top. So velocity is 0 at the top. Now let's see the other side of the parabola. The acceleration always downward arrow, but the velocity in this case also downward. So velocity increases from 0 to -1 to -2 to -3 to -4 to -5 to -6 to -7 to -8 to -9 to -10 to -11 to -13 to -14 and finally -15. So -15. What is the reason it is -15? It is -15 because ball land exactly at the same location the ball starts from. If the ball lands exactly at same location ball starts from, then the velocity is equal in magnitude of the initial velocity but opposite in direction. So this is positive 15, this is -15, which is equal in magnitude but opposite in direction. Okay. So now let's find the displacement. Displacement at location 1 is 0. And displacement is location 3 is 0. Why displacement as location 3 is 0? Is because the ball land exactly same height. Exactly same height. So it fall exactly same height. So if I throw it and it fall at exactly same height, so the displacement would be 0. Now displacement won't be 0. Now displacement won't be 0. But now displacement would be 0 because I allow the ball land exactly same height it starts from. You get it? Displacement on the top we don't know. We'll find out. Now let's find the distance. The distance initial is 0. Distance top and displacement top would be the same. But distance over here is not gonna be the same. In fact, distance over here is 2 displacement in the top. So if displacement over here is 10, then this is 2 times 10. If displacement over here is 11, this is 2 times 11. Because this one is positive. So if I have a parabola like that, I cut it in 2, this is 2, this is 1, and this is 2. Here, right here, distance and displacement are the same thing. Right here, distance not equal to displacement. You get it. Now the acceleration. Acceleration at location 1, 10. Acceleration at location 2, also 10. Acceleration at location 3, also 10. Of course, it is downward arrow. Or you can put negative and you erase the arrow. Okay. Alright, now we're going to find the time in 6 different ways. Number one, we're going to find the time by using the function y is equal to 5t squared. This is called the position function plus 15t. We're going to let y is equal to 0 because right here at location 3 y is 0. At location 3 y is 0. So 15t minus 5t squared. Alright, minus 5t squared is 15t. So if you factor out t, minus 5t plus 15. So t is equal to 0 and minus 5t plus 15 is equal to 0. So minus 5t is equal to minus 15. So t is equal to 3. So t is equal to 0 in the beginning and t is equal to 3 at location 3, and t is equal to 1/2 over here is because this is half the way. Alright, so number 1, we can use the position function. Alright, let's find another way of solving the same problem. This is a quadratic equation. Quadratic equation was invented by Brahmagupta in India. To solve the quadratic function, someone invented quadratic formula, and quadratic formula was invented by Al-Khwarizmi in Baghdad. Nowadays people don't like to talk about Baghdad because Baghdad is associated with terrorism. Back then Baghdad was associated with math and science, and the quadratic formula was invented by Al-Khwarizmi. The algebra is after his name, and we're going to use the quadratic formula to solve this problem, and that is minus b plus minus b square minus 4 ac over 2a. So the b is 15. 15 square is 2 to 5. Minus 4, a is minus 5 and c is 0 over 2 times negative 5. So I have negative 15 plus minus 15 over negative 10. So this gives me 2 answers. Minus 15 plus 15 over negative 10 minus 15 over negative 10. So this gives me 0 and this gives me 3. So I see that I get the same answer. So yes, quadratic formula give us the same answer. Now the vertex should give us the same answer as well. So now let's use the vertex. Vertex is minus b over 2a. 15, a is negative 5. So minus 15 minus 10. Minus minus cancel, 1.5. Why 1.5? Because when we talk about the vertex, we are talking about right here. Vertex is the time at the top, the time when the ball changes the direction, time at the maximum height. That's the vertex. So the time at the maximum height is 1.5. So when you know the time at maximum height, then what you can do, time max times 2, and that gives you the elapsed time. Okay, so yeah, we can use the vertex formula. This is the location 1, this is the location 2, and this is the location 3. Alright, let's see what other formula we can use. Can you use d is equal to vat plus half at square? Yes. The displacement has to be 0 at location 3. Then you get the elapsed time because the ball falls exactly at the same location. So VA is 15. So 0 is equal to 15t minus 5t square. So that means you get 5t 3 minus t. So you have 5t is equal to 0 and 3 minus t is equal to 0. So you get 0 and you get 3 is equal to 3. So yes, you can use d is equal to VAT plus half at square. Now let's see whether you can use this formula, Vf is equal to Vi plus At. Bf at maximum height is 0. So this gives you the time at the maximum height. But you can do other way. You can say Vf is negative 15. Then this gives you the time for the entire trip. If you write B is equal to negative 15. Vi is 15. So you get negative 15 is equal to negative 10t. So you equal to negative 30 is equal to negative 10t. So t is equal to 3. Since you let Bf is negative 15, which is location 3, then it gives you the time at location 3, which is 3. Yes, you can use Vf is equal to Vi plus At. Is there any other formula? Is there any other equation can you use? Yes, you can find the time is equal to delta V over A. So the time is Vf minus Bi over acceleration due to gravity. So T is equal to Vf is negative 15 and Vi is positive 15 over 10. So T is equal to negative 30 over negative 10. So T is equal to 3. So you found many different ways, in fact 6 different ways, 5, 6, to find the time of a free fall. Now next time we're going to find 6 different ways to find the displacement and the distance. 6 different ways. So check the video tomorrow.